What's up, guys? It's time for our practice test review. We're going to review practice test 20. Here we go.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right, let's just get right into it. Number one, here's what it says. 3/4 of the tickets had been sold, and there were 420 tickets left. How many tickets were printed? Okay, so this problem breaks these tickets into two different categories. Number one, how many tickets were sold and how many tickets were left over? Well, if you add them all together, that equals the total number of tickets. Okay, so how do you translate this? 3/4. Well, 3/4 of tickets, T, had been sold. Okay, so had been is a past tense for what verb? Is. How do you say is? Equals. And then I'm going to say S for sold. Okay? And then it says there were 420 tickets left. Okay. Well, that's different than how many had been sold. So if 3/4 had been sold, what fraction were left? Well, 1/4 of the tickets were left. Okay, so let's solve this equation. How do you get rid of 1/4? Well, you divide both sides by 1/4. So T equals 420 times 4/1. Remember, copy dot flop, or just 4. And this equals 1,680 tickets. Okay, done. Good job. Number two says find 3 consecutive odd integers such that the sum of the first and third equals the sum of the second and 13. Okay, we can do this. So how do you say 3 consecutive odd integers? Well, if the first one is n, so this is the first odd integer. Well, how do you get to the next odd integer? Well, how do you get from like 3 to 5? You have to add 2. How do you get from 5 to 7? You have to add 2. So the second odd integer is going to be whatever n is plus 2. So this is the second. And then how do you say the third? Well, if there's 3, like 3, 5, and 7, how do you get from n, the first one, to the third one? You have to add 4. So this works with even integers too. A very common mistake would be to say n plus 1, n plus 3. No, it's still only 2 between each odd integer. Okay, so this is our third. So now we have our little key here. So this guy is going to tell us how to translate our problem. So let's go back to the problem and translate it. Find 3 consecutive odd integers such that the sum of the first and third. Okay, so how do you say the sum of the first and third? Well, this is the first, and the sum is addition. The third is n plus 4. So see how this is the sum of the first and third equals the sum of the second. Okay, so here's the second, and 13. So that tells us the sum of the second and 13. So let's reread this again. So this says the sum of the first and third equals the sum of the second and 13. All right. Since everything's addition, we can actually ignore all the parentheses. So now we're just gonna clean up both sides of the equation. Combine like terms, so this is 2n plus 4. And then combine these terms, that's just n, there's no other n's, plus 15. All right, step 2. If there's variables on both sides, get rid of the smaller one, and there is. So let's do step 2 here. Okay, we're gonna subtract the smaller one, which is that n there, so get rid of n. From both sides, you're left with just one n over here, plus 4 equals 15. Next step, get rid of the constant on the variable side. So we're going to get rid of this plus 4 by subtracting 4. So n equals 11. All right, well, that tells you what n is, but now you have to answer the question. The question says, find 3 consecutive odd integers. Well, if the first one's 11, what are the next two? 13 and 15. Or you could just plug them into your little key here, and there's your answer. Boom, done, good. Okay, moving on to number 3. 2 dice are rolled. What is the probability that the sum of the top numbers on the dice is 10? So what are your options? You've got, well, how do you roll a 10 on a pair of dice? Well, 1, you can't roll 1 with anything. But if you listed out all your different possibilities, here's what it would look like. 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, or you could get a 2 and a 1. My hand kind of hurts a little bit. It's a lot of writing. So how many different possibilities is that? Okay, so what is probability? Remember, probability equals the number of favored outcomes over the total number of outcomes, possible outcomes. So this is number of favored, or what you're looking for. So what you're looking for over total number of total possibilities or total outcome. Okay? So what are you looking for? If you're trying to find the probability of a sum of 10, how many is that? Well, let's see if we can figure out which ones add up to 10. All right, well, you can't roll a 3 and anything else to get up to 10. The highest you can get with a 3 and something else is a 9. So it's gonna be 4 and 6. So there's a possibility. A 5 and a 5. Or a 6 and a 4. So there's only 3 out of the 36 total possibilities that will give you a sum of 10. So 3 out of 36. So that's the probability, and you can reduce it to 1/12. Okay, does that make sense? Good job, boom, done. All right, number 4. Number 4 says Justin's test grades were 78, 84, 74, and 80. It's kind of a average, below average student. Whatever, we're gonna pray for Justin. What is his weighted average if the test grades are weighted 4, 5, 2, 3, respectively? Remember, respectively means I'm saying them in the same order as I said the tests, okay? So that 78 has a weight of 4, that 84 has a weight of 5, that 74 has a weight of 2, and that 80 has a weight of 3. So basically that means we're gonna count that first test score 4 times, we're gonna count the second test score 5 times, and so on. So we're gonna count 4 78s. Okay, so I'm gonna say average equals 4 78s plus 5 84s plus 2 74s plus 3 80s. All right, now how many total scores are there? Well, there's only 4 tests, but remember we counted these scores multiple number of times. So we counted that 78 4 times. So really there's 4 78s, there's 5 84s, there's 2 74s, and 3 80s. So how many total scores did we count? Well, 4 plus 5 plus 2 plus 3. Okay? So let's do that. So that's really just 14 scores, okay? So let's do that math, and what do we get? I'm not afraid to use a calculator. I'm not ashamed. So we're gonna say 4 times 78 plus 5 times 84 plus 2 times 74 plus 3 times 80, all divided by 14 is 80. Looks like Justin is a B student. That's okay. He can do better though. Okay, number 5 says find the equations of these lines. All right, so let's zoom in here. Okay, so what's the equation of line A? All right, so remember when you have a vertical line, which is what line A is, let's just circle line A here. Here's line A. When you have a vertical line, remember that's just x equals wherever the line is. So it looks like it passes right here at x equals 3. So the equation for line A is x equals 3. If it was a horizontal line, then it would be y equals wherever that passed the y-axis. But this is a vertical line, so it's x equals wherever it crosses the x-axis. And if you think about every point on this line, x equals 3 everywhere on this line. Here's 3, 0, 3, 1, 3, 2, 3, 3, 3, 4, and down there too. Okay? So that's A. The vertical lines and horizontal lines are pretty easy. You just say x equals something or y equals something. All right, well, let's look at B. B is a little bit trickier. Remember, the shortcut is you have to find what the slope is and what the intercept is. So remember, slope-intercept form is y equals mx plus b, where m stands for slope, which is just rise over run, and b stands for y-axis intercept. Okay, this is where it crosses the y-axis. Okay, well, let's see if we can find that right there. So where does it cross the y-axis? At -1. So this is going to be -1. And then our slope is rise over run. So if you're going from point to point, you can pick any 2 points. These are some nice points here. So this goes from here to here. So how many does it go down? It goes down 1, right 1. So how do you say down 1? -1. So it goes down 1, right 1. And then how do you say right 1? Well, that's a +1. So what's -1 divided by +1? Just -1. So let's rewrite our equation. Y equals slope, which is -1, x plus the y-axis intercept, which is -1. Okay? That's it. This is fine. It's probably simpler when you have a -1x to just say -x and then plus -1. You can leave it like that, or you can say -1. Both of these are the right answers. So if you put one of these, that's correct. Good job. Okay, number 6 says this. We're gonna graph 4x plus y minus 4 equals 0. Okay, so for this, we're gonna pull up our coordinate plane. So let's grab that. Okay, so there's a couple different ways you could do this. We're gonna do it in both ways. We're gonna do slope-intercept form first. So remember, put it in slope-intercept form. So step 1, put in slope-intercept form. What does that mean? That just means get y by itself. All right, well, let's do that. Okay, so 4x plus y minus 4 equals 0. So we're gonna get rid of everything on the left side except y. So let's get rid of that -4x, or that 4x first by subtracting 4x from both sides. Remember, the shortcut to just bring something over there is to just negate it. So now we're left with y minus 4 equals -4x. Okay, now get rid of the 4. Add 4 to both sides, add 4 to both sides. Y equals, what is that? Well, you can't combine those together because that's a variable term and a constant, so you just leave it, -4x plus 4. Okay? All right, so now we have to determine what our slope is and what our intercept is. So remember, our slope is whatever the x is being multiplied by. Slope equals rise over run. Well, this guy is, this is your slope, so slope equals -4, okay? So what's your rise over run? Just -4 over 1, right? Remember, you can make a fraction out of anything. So that's your slope, -4 over 1. So this just means down 4, right 1, okay? All right, what about our y-axis intercept? Remember, that's just your constant on that side. So that's where it crosses the y-axis. So this guy right here is our y-axis intercept. All right, so let's apply our slope here. So we're gonna go down 4, 1, 2, 3, 4, and then over 1. So right 1. So now we're gonna connect these dots here. And that looks pretty cool. You can go a couple more points if you want. Down 4, -1, down 4, -1. That works. And there it is. We just graphed it. Boom, we're done. Good job. All right, the other way to do it is just to pick some XY values. And you can do this just to be safe to make sure you're doing it right. So let's pick some X's and Y's that will work in this equation. So if you pick 0, well, what does Y equal? Well, let's write our equation here. Y equals -4x plus 4. So if Y is 0, you plug in a 0 right here and it gets 0 plus 4, so Y has to be 4. So if Y is 1, you would get -4 times 1, which is -4 plus 4 equals 0. If Y is 2, you get a -8 plus 4 is -4. So if you graph those points, 0, 4 is right there, 1, 0 is right there, and 2, -8 is right there. That works. Done and done. Okay, number 7 says simplify this craziness. So let's rewrite it here. 8,000 times 10 to the 8th, all times 0.000006, all over 20,000 times 0.00000003. So here's what we're gonna do. We're just gonna rewrite everything in scientific notation. So 8,000 times 10 to the 8th, that's kind of confusing. Let's write 8,000 first. So we're gonna go 8.0, or just 8. So remember the steps to putting stuff in scientific notation. Number 1, put the decimal after the first non-zero digit. There it is. And then you're gonna multiply by a power of 10 that will move it back to its original starting place. So we're gonna have to move it 3 to the right. Okay, so that's 10 to the 3rd. But we're already multiplying by this 10 to the 8th, remember? Okay, and then let's do this one. Well, this is just 6.0. times 10 to the, well, how do you get it back to its original place? 1, 2, 3, 4, 5, 6 to the left. So I have to go left 6. All right, so that's all over this guy. Well, let's put this one in scientific notation. That's 2 times 10 to the 1, 2, 3, 4. And then this guy is gonna be 3 times 10 to the, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 to the left. All right, now we simplify. So let's simplify the top. 8 times 6, 48. And then let's add our exponents of the powers of 10. Remember, when you're multiplying powers of 10, all you do is add the exponents. So 11 plus -6 is +5. And this is all divided by 2 times 3 is 6. And then add the exponents, -6. Now we're gonna just do our division. 48 divided by 6 is 8. And then let's just divide our powers of 10. Remember, when you divide powers of 10, you subtract the exponent. So this is gonna be times 10 to the 5 minus -6. All right, don't be fooled by that. Chicken scratch. So this is actually 8 times 10 to the 11th. Done. Boom. Good job. All right, well, there's a B to our 7. So let's do 7B. Here's what 7B says. 0.00005 times 10 to the 12th, all times 900,000 times 10 to the -8th, all divided by 0.0003 times 3 million. Whoa. Okay. All right, one step at a time. Let's rewrite this guy. This is just 5 times 10 to the, how many places you have to go to get it back? 1, 2, 3, 4, 5 to the left. So times 10 to the -5th. All times 10 to the 12th, right? Multiplied by this guy, 900,000, is just 9 times 10 to the 1, 2, 3, 4, 5. All times 10 to the -8th. This is all divided by this guy. So remember, this is just 3 times 10 to the 1, 2, 3, 4. So 4 to the left, so negative fourth. All times 3 times 10 to the 1, 2, 3, 4, 5, 6. Positive 6. All right, let's simplify that. 5 times 9 is 45. And then our powers of 10, we're just gonna add all these exponents together. Let's see, we have a positive 17 and a negative 13, so that's just 10 to the 4th. All divided by 3 times 3 is 9, and 10 to the negative 4th times 10 to the 6th is 10 to the positive 2. Now we're gonna divide. 45 divided by 9 is 5, and 10 to the 4 minus 2. I don't think we have to chicken scratch this because these are two positive numbers we're subtracting. 4 minus 2 is 2. Boom. Done and done. Okay, number 8. Finally, we get to factor some stuff. All right, here's what 8 says. 49x squared minus 9y squared. Okay. Remember the steps to factoring. First, see if there's anything you can take out of both of these. You can't take anything out of 49 and 9. You can't take anything out of x squared and y squared. So next step, see if it's a difference of 2 squares. Yes, it's a difference of 2 squares. These are square rootable. Remember how you factor a difference of 2 squares? It's the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Okay? So this is 7x plus 3y, and then 7x minus 3y. Done. That was awesome. Okay, let's look at number 9. This looks like another difference of 2 squareds. It's a difference because you're subtracting 2 things, and it's squares because it's square rootable. Variables with exponents are square rootable if the exponents are even. And then 9 and 64 are square rootable because they're perfect squares. So square root of the first plus the square root of the second, square root of the first minus the square root of the second. So 3mnx plus 8px times 3mnx minus 8px. Okay, so see how this is the square root of 9m squared n squared x squared, and this is the square root of 64p squared x squared. That's it. Boom, done, done. Number 10. Okay, first step to factoring, see if there's anything you can take out. There is. So let's look at that. So what can you take out of all 3 of these? What do they all have in common? They have an x in common. And here's a side note. Remember, make sure that the highest degree term is positive. So we're gonna take out a negative x. This is important. When you take out a negative x, you're left with, you get rid of that negative sign and it's positive. You take an x away from x cubed and it's x squared. You take a negative away from a negative and it's positive, and then there's 4, and then x. Okay, take a negative x out of positive 45x, and you get a negative 45. Okay? It may be easier just to write these as separate division problems. So you're gonna just divide everything by negative x. Okay? And what are you left with? Well, negatives cancel and you get positive. X cubed over x is x squared. Negatives cancel and you get positive, and then that 4 doesn't change. The x squared over x is x. And then 45, the x's cancel, but it's a negative, so this is what you're left with. All right, now there's another step to this, because step 3 in factoring is look for a factorable trinomial. We have one. So remember, cheeks and tats, x and x there. All right, remember the magic question. What factors of negative 45 will add up to 4? Or what 2 numbers multiply to get negative 45 but add to get 4? Can you do it? Good. Positive 9 and negative 5, because 9 times negative 5 is negative 45, but 9 plus negative 5 is positive 4. So when you FOIL that out, you get x squared, negative 5x, positive 9x. Those combine to positive 4x, and then negative 45. Boom, you're done. All right, last one to factor. is 3a squared minus 3a minus 60. Okay, first step to factoring. Take out a GCF, take out a greatest common factor. 3 goes into all of them. A squared minus a minus 20. There's no difference of 2 squares, so it's a factorable trinomial. So a and a. What two numbers multiply to get negative 20 but added together will come down to a negative a? Well, negative 5 and positive 4. Because when you factor that out, you get a squared, positive 4a, and negative 5a, which combine to a negative 1a, and then negative 20. Boom, done. Awesome. All right, moving on to number 12. Here's what number 12 looks like. M plus 5 over 3 minus 3 over 2 equals 2m minus 6 over 4. Okay, I'm not sure we talked about this, but I'm gonna introduce you to the F-bomb. Okay, it's not what you think. The F-bomb is what's called the fraction bomb. Okay, so the fraction bomb is a bomb that you can drop on this equation and it'll get rid of all the fractions in one swoop. Okay? Well, the fraction bomb is just the least common denominator. All right? So what's the least common denominator of 3, 2, and 4? Well, the least common denominator is what they all go into. So that is 12. So I'm going to multiply everything by this fraction bomb. Okay, so I'm gonna multiply both sides of this equation by 12. And you're gonna see what happens. It's beautiful. All right, here we go. So first one is 12 times m plus 5 over 3 minus, because remember we're distributing, 12 times 3 over 2 equals 12 times 2m minus 6 over 4. Okay? Well, what happens? Well, let's look. So if you're multiplying fractions, remember you can cross reduce. So look what happens. The 3 and the 12 reduce to a 1 and a 4. The 2 and the 12 reduces to a 1 and a 6. The 4 and 12 reduces to 1 and 3. So now you don't have any denominators. How awesome is that? So now let's just multiply right across. So we're gonna distribute all this. So 4m plus 20 minus 18 equals 6m minus 18. That's called the F-bomb. So we dropped an F-bomb on that equation. So that might seem confusing right now. You could do it the long way and find a least common denominator, which is 12. So you rewrite each fraction with 12 as the denominator. Whatever you do to the bottom, do to the top. You could do it that way, and that's fine. Or you can drop an F-bomb. Okay, so let's simplify it. Let's follow the steps to solving equations. So first step, get rid of parentheses, done. Second step, combine like terms. There's only a few right there. So 4m plus 2 equals 6m minus 18. Second step to solving equations is to get rid of smaller variable term. If you have variables on both sides, you do. So let's get rid of that. So then you're left with 2 equals 2m minus 18. Third step to solving equations is to get rid of constant on variable side. This time the variable's on the right side, so we're gonna add 18 to both sides. So 20 equals 2m. Last step to solving equations is divide by variables coefficients. So divide by 2, divide by 2, m equals 10. All right, boom. That was fun. We got to use an F-bomb. It was fun. All right, number 13. Negative, bracket, negative 2, parenthesis, x minus 5, parenthesis, minus absolute value of negative 2, equals 3x minus 4. All right. A lot of you are probably going to get this wrong. Yeah, I said it, okay? But not because you don't understand it, but because there's so many opportunities for you to mess this up. Let's eliminate those possibilities. So we're gonna simplify this equation first. First step to simplifying is get rid of parentheses. Well, there's lots of parentheses or types of parentheses. Remember, there's actual parentheses, there's brackets. And then these absolute value symbols are also a form of parentheses or symbols of inclusion. So let's do that first. So let's get rid of our parentheses here, and then we're gonna simplify that as well. Everything else we're gonna leave alone. So I'm not gonna touch anything else here. So this is a negative 2x, and remember a negative 2 times a negative 5 is a positive 10, minus, what's the absolute value of negative 2? Well, that's just 2. Okay, and that all equals 3x minus 4. All right, we still have parentheses here. Well, how do you get rid of parentheses? Remember, you distribute. Well, the only thing you're distributing is this negative sign, okay? So let's distribute this negative sign to everything in here. And we could have combined like terms in there first. It doesn't matter. We're gonna just negate everything in there and get rid of these brackets. So that's negative negative, which is positive 2x. Negative times positive 10 is negative 10. Negative negative makes a positive 2. All right, that all equals 3x minus 4. We still have a couple things to do, or one more thing to do. We just have to combine these terms. That's the second part of simplifying both sides of the equation. So this is negative 8, because remember, it's a negative 10 plus a positive 2. Equals 3x minus 4. All right, second step to solving equations is get rid of the smaller variable term. It's 2x, so get rid of 2x. So you're left with negative 8 equals 1x, or just x, minus 4. All right, third step, get rid of the constant on the variable side, which is the right side now, so add 4 to both sides. So negative 4 equals x, and then you're done. You don't even have to do step 4, which is divide by a variable's coefficient, because there is none. Good, good? All right, good job. Next, number 14 says given RATA equals RBTB, that's our mother equation, right? That's our main equation. So then it gives us some more values here. RA equals 15, RB equals 3, and TB equals 6 minus TA. All right, so here's what we're gonna do. We're gonna plug in 15 for RA. RA is right there. We're gonna plug in 3 for RB, which is right there. And then we're gonna plug in 6 minus TA for TB, okay? So let's do it. So the only thing that we're not replacing is this T of A, okay? So let's plug in 15 for RA, so 15 now times TA equals RB, which is 3, times TB, which is 6 minus TA. And remember, we need those parentheses there because this is RB times all of TB. So if you just had 3 times 6 minus TA, that doesn't work. You have to multiply 3 times all of T of B, okay? All right, first step to simplifying equations is to get rid of parentheses. So we're gonna get rid of that. So 15 T of A equals 18 minus 3 T of A. Second step to solving equations is to get rid of the smaller variable term. And over here, it's negative 3TA, so to add 3TA to both sides. Okay, and so we're left with 18 T of A equals 18. All right, you can skip step 3 because there's no constant on the variable side. So now you're just gonna divide by 18. Well, that's nice. T of A equals 1. All right, what do the directions say? Well, the directions say find T of A and T of B. All right, well, now that you know what T of A is, you can plug that in right there. So T of B is gonna be 6 minus whatever T of A is. Well, T of A is 1. So T of B equals 5. Boom. Nice. All right, number 15 says use elimination to solve this. Okay. Here's what the system of equations is. 2x plus 5y equals 24. X minus 3y equals negative 10. Use elimination when you have opposites of the same variable. So if you have a positive 2x in the top equation and a negative 2x in the bottom of the equation, when you add them together, they'll cancel. Well, that's not the case, but we can make it so. So what we're gonna do is we're gonna multiply both sides of this equation by -2. And let's see what we get. Well, we get a negative 2x. Negative negative is positive 6y equals negative times negative is positive 20. All right? Okay, so now, see how this equation, now if we add this to that, it'll cancel itself out. So now we're just gonna kind of get rid of that. We don't need that anymore. So now when we add them together, we get 2x and negative 2x cancel. And then we get 5y and 6y is 11y. And then 24 plus 20 is 44. That was cool. And you'll only ever have to do the last step of solving equations, which is divide by coefficient. So y equals 4. So that's half of our problem. Now we need to find x. What's the easiest equation to solve for x? Well, probably that one that we just crossed out. So let's rewrite that guy. So that's just that's just x minus 3y, which is our 4, equals negative 10. So let's simplify that. X minus 12 equals negative 10. Add 12 to both sides. X equals 2. All right, so let's just make sure these x and y's work in the other equation. So 2 times x, which is 2. 2 times 2 is 4, plus 5 times 4 is 20. 4 plus 20 is 24, check. So you can write it like this, or remember the cool kids are doing this these days. 2 comma 4, writing your x coefficient first and then your y coefficient. All right, well done, good job, moving on. Okay, number 16 looks like this. 8 over xy minus 2 over x squared plus 3 over x plus y, and it just says simplify, or it just says add. All right, so what do we need to add fractions? We need common denominators. So how do we make all these guys look like each other? Well, this one needs another x to look like that, and this guy needs a y to make it look like that. So now these two are the same, but how do we make it look like this? Well, this is like a separate factor. So unfortunately, this x, you can't just add a y over here and make it look like that. You can make least common denominators by multiplying things together. So we have to multiply this by an x squared y to look like that, and this guy needs an x squared y. But then this thing needs an x plus y. So whatever you do to the bottom, do to the top. So it's messy, but this is what you gotta do. All right, let's simplify the top here. So we're gonna distribute. That's 8x squared plus 8xy. Distribute that, but we're subtracting this whole thing. Okay, this is all over x squared y times x plus y. Okay, then we're subtracting, let's distribute this. 2xy plus 2y squared, all over that same denominator. Plus, these just squish together, so 3x squared y, all over x plus y. And then we'll just write this over here, just so it looks pretty and the same. Okay, so this is 3 separate fractions still, but they all have the same denominator. So we can add them all together. So this is 8x squared plus 8xy minus, remember you're subtracting both of these. So you're subtracting 2xy and you're subtracting a 2y squared plus 3x squared y, all over that same denominator. Okay, are you done? Well, technically you can go a little further because look what you got here. You've got like terms. So these guys can combine together for a final clean simplified answer of 8x squared plus 6xy minus 2y squared plus 3x squared y, all over that crazy denominator. Okay, so this is your nice, pretty answer. But show as much work as you can so you get plenty of partial credit. It's gonna be awesome. Okay, number 17. All right, we're gonna simplify these radical expressions, and then we're gonna see if we can combine any terms here. So your first step is to try to hunt down those perfect squares that are hiding inside of those radicals and take them out of there, okay? So remember your magic question. What, if any, perfect squares are inside of 45? Well, 45 can be separated square root of 9 times square root of 5, okay? And this 3 is still 3. So does anybody have an issue with this? Because this is just 3 times the square root of 45. Well, the square root of 45 is just square root of 9 times the square root of 5. Okay, so far so good? All right, what is the biggest perfect square that you can take out of 80? Remember your perfect squares are like 4, 9, 16, 25, 36, and so on. Well, the obvious answer is like, you could take a 4 out of there, but there's a bigger one. So I'm gonna take out, remember we still need this 5, 16, because square root of 80 is the square root of 16 times the square root of 5, because 80 is just 16 times 5. Minus, all right, bring down the 4. What's the biggest perfect square that goes into 20? Well, just 4. So square root of 4 times the square root of 5. All right, now what you can do is you can simplify all these perfect square radicals, because the square root of something should be written as its true identity, which is just 3 here. Square root of 16 is 4, square root of 4 is 2. Okay, so 3 times, and then this is just times the square root of 5. All right, so we can just simplify this. So we get 9 radical 5 plus 20 radical 5 minus 8 radical 5. Hey, look, they're all radical 5, so these are like terms or like radicals. So you can combine them together. 9 plus 20 minus 8 is 21 radical 5s. Boom. All right, number 18. We're gonna simplify this, and we're gonna write as a simple fraction with all exponents positive. Okay, so let's not worry about that right now. Let's just start dealing with these crazy exponents. All over 3x minus xy to the negative 2. Okay, remember the rule of negative exponents is you can switch the position if you switch the sign. So a negative exponent like x to the negative 1 is really just 1 over x to the positive 1. You can switch a number from the top to the bottom by just changing the sign of the exponent, okay? At first glance, it looks like, oh, let's just bring everything upstairs. Well, you can't do that because these are not multiplied together, they're added together. So we need to rewrite these as each individual term with the exponents in the right place, okay? So we're gonna write this term, and this guy needs to go downstairs. So this needs to go under right there. Okay, so let's rewrite that y squared z all over x to the negative 1 becomes an x to the positive 1. All right, and then what about this one? Well, this guy will go downstairs. So this is minus z over y, okay? And then over here, we just have 3x minus, well, let's put that y squared, y to the negative 2 downstairs as a y squared. So this is over y squared. Okay? So now we have a subtraction problem of fractions on top and then a subtraction problem of fractions on the bottom. So let's subtract the fractions. Here's what we need. So let me rewrite that. Okay, and you can only subtract fractions with fractions, so let's do that. All right, now I'm gonna find some common denominators. How do you make this x look like that? Well, it needs a y, and then we're gonna multiply by another y up there. How do you make this y look like that? Well, it needs an x, so we're gonna put an x there, okay? All right, well, how do you make this guy look like that guy? Well, that just needs a y squared, because 1 times y squared is just y squared. All right, so now let's rewrite our nice fractions here with our denominator. So this is y squared z y minus xz all over xy. Because remember, when you have the same denominator, you just add or subtract the numerators. All over or divided by 3xy squared minus x over y squared. Okay, so this is a division problem. So we're gonna copy, and look, y squared zy, that's just y cubed. Z minus xz all over xy. We copied. Now we're gonna dot. So we're changing that division problem into a multiplication problem. And then we're gonna flop the second fraction, or in this case, the bottom fraction. So y squared all over 3xy squared minus x. Okay, and then we're gonna do something fun. We're gonna try to cancel things that can be canceled. Well, these are subtraction problems, so you can't really cancel things in there. This y squared and xy, you can take a y out, so that cancels. So now when we multiply across, we get y cubed z minus xz over x times this whole thing, 3xy squared minus x. That was involved. That was challenging. Okay, the directions say write as a simple fraction with all exponents positive. All exponents are positive. All right, 2 more problems, then we're done. Number 19, and there's a A and a B. So 19A says 9 radical 5 is an element of which subsets of real numbers? Remember our subset of real numbers. There's only 2 major subsets of real numbers, which are irrationals and rationals. Okay? But then underneath the rationals, inside of the rationals, you've got your integers. Inside the integers, you got your whole numbers. Inside your whole numbers, you got your natural or counting numbers. Okay? So which part is this? Well, irrats are anything with a radical of something you can't take the square root of. So that is an irrational number. And that is the only subset of real numbers where that belongs. Technically, it's real numbers are a subset of real numbers, so you could say irrationals and reals, but this is the only proper subset for A. All right, well, what about B? B is the cubed root of negative 125. Well, there is a radical there, but the first thing you should always check to see if you can simplify that radical. Well, you can actually take the cubed root of negative 125. It's just negative 5. Because what happens when you multiply negative 5 times itself 3 times? It equals negative 125. So this is just negative 5, and that's just an integer. So it's an integer. So if it's an integer, then it's everything above integers, so it's rational numbers as well. Okay, that's 19A and B. All right, let's look at 20. 20 is find the perimeter of this figure. All angles are right angles, dimensions are in centimeters. Okay, so let's dig up our pre-algebra roots here. See if we can figure this out. This is drawn very poorly, but you still love me. All right, perimeter is just the sum of all the sides, right? Well, the problem is we're missing like this side, this side, this side, and this side. Well, let's see if we can figure this out. This will be fun, okay? So if this is 33, that means all of this is gonna add up to 33. So this and this and this have to add up to 33. So we can say that our perimeter is 33 plus this 33. Okay. Plus, all right, let's look at our vertical lines now. We're gonna say 19, because there's our 19. Then we're gonna say 13 and 7, because those are what are given, right? So this guy goes there, it's gonna get messy, sorry. All right. Well, what are we missing? We're missing this guy right here. All right, so let's see if we can figure that out. I think we could do it. So if I figured out this line right here, this whole thing has to add up to 19, right? This whole thing has to add up to 19. Well, that means this guy is gonna be 13, so this has to be 6. So if this is 6, then what's this? Well, 19 minus 6 is 13. That was fun. So we just need another 13. Add it together. What is that? 33 plus 33 plus 19 plus 13 plus 7 plus 13 equals 118. All right, and these are in centimeters. So 118 centimeters is your answer. So that's it, guys. Good job. The actual test will look so much like this, it's not even funny. So if you can understand this and what we did to figure all this out, then you're gonna do fine on your test, okay? But let me know if you have questions. Good job.
Black man!